you, Tim. And there's a change. All right, well, thank you. Thank you for having me in. I'm here to be a little bit evangelical about Apophis in 2029 because this is a once per 1,000-year opportunity for both science and planetary defense. And it turns out the magic date is April 13th, 2029. This is really happening. This is not science fiction. This is science fact. Apophis is coming. April 13th, 2029 is a Friday. This is a 350-meter asteroid that is going to pass within 5.8 Earth radii. And an object this large passes this close to Earth once per 1,000 years. And I always emphasize in public that Apophis is going to miss the Earth, Apophis is going to miss the Earth, and Apophis is going to miss the Earth. And they still carry a wave. But it will be a close shave. This is an object 5 times larger than the Tunguska body and 100 times more massive. Very impressive event. And the close encounter is inside the distance of geosynchronous satellites. That's how close this encounter is, 1/10 the lunar distance. All right, so we know since the time of Roche 1849 that things happen to small bodies when they have close planetary encounters. And in fact, this has been studied for near-Earth asteroids. This is a paper by Richardson et al., trying to understand some of these strange elongated shapes we see for near-Earth asteroids. Now, we also know there are other things that can affect the shapes of near-Earth asteroids or inner solar system asteroids like Yorp spin-up. But that may be giving us that classic sort of diamond shape, sort of the Bennu and Ryugu shapes. And some of these other shapes may be from tidal stressing, tidal disruption, and rearrangement from close planetary encounters. So anyway, there's a wide range of possible processes here that we can directly explore thanks to this Apophis encounter. And again, we know it's coming. We know it's coming. We have 10 years to think about it and plan for it. All right, Shoemaker-Levy 9, of course, experienced the close planetary encounter. Now, to be sure, at 5.8 Earth radii, Apophis is outside the Roche limit. So we're not going to see anything dramatic like the tidal stressing in the Richardson et al. Paper. But nevertheless, it's close enough that it's an open question of what will Apophis do? What will Apophis feel? So the things that we do know is that the Earth encounter is going to alter the orbit of Apophis, and we know that it's going to alter the spin state of Apophis. And what we don't know is whether there will be internal seismic shaking in a small amount, or if any, seismic vibrations induced in the asteroid. This reminds me of the Deep Impact mission, where the whole motivation for sending an impactor into the comet was to find out what happens, because the range of uncertainty of how comets are put together is so large that we just simply had to do an experiment to find out. And DART is the same way. In this case, it's nature that's doing the experiment for us. I think once per 1,000-year experiment, nature is doing it for us. So we do see evidence of landslides from seismic shaking on Itokawa. We don't know the cause of seismic shaking. Could have been planetary encounters, could have been collisions or other effects. But we do see evidence broadly in the near-Earth object population for planetary encounters resurfacing asteroids. So let me just show you this data. Spread vertically there is spectral information. The objects plotted above the line have spectral properties that indicate they are dormant, long exposed surfaces to the space environment. We call them space weathered surfaces. And the objects below the line are objects that have very fresh spectral surfaces, like freshly ground up meteorites in the laboratory. And we think that these asteroids these are near-Earth objects whose surfaces have somehow been refreshed. They're young surfaces compared to those above the line. And it turns out what's separating them horizontally here on this plot is dynamical information. This is the minimum orbit intersection distance, or MOID, and that tells you whether or not these objects could have had close Earth encounters in the past. And it turns out this cluster of fresh surfaces among NEOs is predominant among those objects that have the capability of experiencing a close Earth encounter within the last 500,000 years. MOID is a statistical analysis. We can't say for sure if and when these encounters happen. All we know is that they have orbits that are capable of close Earth encounters in the past. And that's where we see the fresh surfaces. So one idea is that these are near-Earth objects that have experienced close planetary encounters. Their surfaces have been shaken up, and that's in recent time, 500,000 million year time scales. And that's short on the time scale of space weathering. So broadly speaking, we think the near-Earth object population tells us that this actually happens. All right, so this is really a decadal, if not a 1,000-year opportunity to study the interior structure of a potentially hazardous asteroid. And this challenge was posed to a class at MIT, and they came up with a mission concept study. We called it MIT Project Apophis. 50 years ago, there was MIT Project Icarus. This is MIT Project Apophis. But the bottom line here, and the takeaway message that I want you to have, is we have the potential for a new era in small body science. It's asteroid seismology. We can move the field ahead into a completely different realm than anything we've ever done before. And that's what this opportunity provides. All right, so we know how to characterize asteroids. I'll show you we have a lot of data on Apophis. In my mind, the opportunity here is all about the encounter. It's all about the encounter. It's all about the encounter. What happens during this 30-hour period when Apophis is inside the orbit of the moon and then at the time of closest approach and just after closest approach? What's going to happen? So if we can measure it, then we can address a science question of understanding the internal state and internal structure of remnant planetesimals. Think about it. We can see how these guys are put together. Think about them from a science point of view. Now think of a planetary defense question. We can understand the internal state and internal structure of a potentially hazardous asteroid. And it's the same question for science and for planetary defense. And it's not necessary that Apophis itself is going to threaten us in the future, but if and when we ever encountered an object that was going to threaten the Earth, wouldn't it be great if we understood the internal structure of these potentially hazardous asteroids? I think the information we can gather from Apophis would be absolutely invaluable in the case that we ever actually needed it. And this is our chance to do it. Nature's providing for us. It's nature performing this experiment for us. I think we have to take advantage of it. All right, so I want to point out that we do know a bit about Apophis's physical parameters, thanks to radar work by Marina Brozovic, light curve work from Peter Provecht and co-authors. We know a good estimate of its size. It's very slowly spinning and fastly precessing, probably from a previous Earth encounter. This is not Apophis's first rodeo. It has probably had one or more other close Earth encounters that have bumping its way through the Earth's tidal stresses. And so it's been here before and it's coming back soon. We also know about its composition. It's an SQ type asteroid. We've done detailed mineralogic modeling of the spectral properties out into the near infrared. We get a very good spectral model fit to LL chondrite meteorites. And the fact that we can make a meteorite link allows us to know a lot about the mineral and material properties of the object. So we have a pretty good basis set as to what Apophis is and what kind of basic ingredients that we're dealing with. But what we don't know is, how is it put together and how is it going to respond to these tidal stresses? All right, so the last thing I'll say about Apophis is this is going to be an amazing worldwide event. If you see the little numbers there, that's the magnitude of Apophis, visible magnitude, and let's see if this graphic will take off from this computer. It actually goes zooming across the sky up to third magnitude. Oh, it's I don't know, apologize, but this graphic is so much cooler when it actually works because it brightens to third magnitude and goes zooming across the sky. Why it cycles after just a few before it gets interesting, I don't know. But I'll show it to you on the laptop. All right. The point is that on the night of April 13th, 2029, that evening, 2 billion people on Earth will see this asteroid buzzing across the sky. 2 billion people are going to see this. And they're going to wonder, what is the science community doing? And we can get in front of it now and have an answer and take advantage of this as an opportunity. 2 billion people are going to see it and are going to ask. And I think we owe it to have an answer. All right, so if you didn't catch on yet, I think Apophis is the poster child for planetary defense. And in fact, thank you to several people in this room, several people online. This was brought forward as a proposal for a special session at the upcoming Planetary Defense Conference, and several people here and online made it work. And so there will be an Apophis special session on Tuesday. I think that's Tuesday of the Planetary Defense Conference week. And we are 10 years away and counting. 10 years away and counting, which is not a long time for planning any kind of major effort. All right, so I come to SBAG for a particular purpose, is to suggest that you might think about issuing a finding about Apophis. And I simply suggest that, it gets recognition as a once per 1,000-year opportunity for science and planetary defense, and that SBAG recognizes this opportunity and encourages the community to think about what this encounter, what's really physically going to be happening with this encounter and how we might take advantage of it. So that's offered for your consideration. And related to this is, I think that Apophis, and to the extent that the SBAG would carry this forward, the Apophis opportunity should be in the decadal survey. Good gracious, it's going to be a fantastic event, probably the asteroid planetary encounter event of the decade. And I can't see how it's not in the decadal survey in terms of saying it's going to happen and what would be the value, some assessment of the value of making the measurements. So with that, I'll conclude. I'll simply put up the URL. This is the MIT student study on Apophis mission concepts. I'm not here to advocate for any particular mission or missions at all, just that this is coming. We need to seriously evaluate what's going to happen and how we might take advantage of it. So with that, I'll stop and take questions. Thank you.
Do we have questions for the evangelist? Yes. Do we have the microphone?
You can shout your question. I'll repeat it.
Head-on rendezvous is notoriously expensive also. It's much better for science than exiting the European system, but I understand why. I am wondering, what's the consensus among the community? Do they want to rendezvous days out, weeks out, months out, years out?
Okay, so the question is, how do we do this? Rendezvous is not the least, it is not inexpensive. All I can do is just speak to the MIT study. There have been European studies. The various organizations are making studies. I think they'll each reach their own conclusions. Our conclusion was to arrive about a year in advance, thoroughly characterize it before, try to make measurements during, and then thoroughly characterize it after to see what changes there were. So, we know how to do that. Going to an asteroid and characterizing it is now our forte. But this, so I think we need to characterize it for understanding the encounter. But to me, it's all about the encounter. What can we optimize about the encounter?
So your time to launch isn't 10 years, it's more like 8 years.
In the MIT study, August 2026 was a launch window that we found.
Okay.
So that's soon, ladies and gentlemen.
Take Andy and then, so we'll take Andy first.
Dr. Rivkin.
Binzel. Yeah, Apophis is obviously going to be a great opportunity. It's going to be an amazing outreach opportunity. There was at least one PS3 study that involved an Apophis mission So there are, as you noted, multiple mission concepts out there. I guess the question is whether this is the best way to get that science, or whether arguably saying, okay, you know, we'll land somewhere, we're going to put down seismic stations, should we not also put our own signal, you know, our own explosives, unknown charge? So I guess the question would be, the question would be, can you comment on that? And then also, are there unknowns involved with the fact that the Earth is causing the seismic disturbance, and there are potentially uncertainties associated with that?
Yes. No, I think it's open. I think that's this is coming. This is going to happen, and I think we're just really beginning to have deep thought about it. And I don't want to try to prejudge what the right thing to do is, but that's why I think it belongs in the decadal, and why just raising the community awareness now is to do these studies and do these evaluations. And I don't know how they'll be selected.
Sure, I think being in the decadal, right, depending on the level that you're thinking, that whether it's appropriate to say, here's an opportunity, or whether to say, here is the science, and the science has already been prioritized as important, and so the Apophis will rise to the top because they have the wrong science question, instead of kind of going the reverse way of, here's this amazing opportunity, let's think about how to handle it. So that would be kind of the
Yeah, so I think the science priority is what can you learn about interior structure that we can't learn in any other way, in any thorough ways, is, what is the opportunity that nature is handing us? And that's still an open question. I still think that's an open question. And I think it's going to be like deep impact. We ought to do it because I think the predicted answers are going to be all over the map, literally.
Professor Binzel. This is Herb Bauer from the University. I wanted to ask you, first of all, I want to start off by pointing out that in last year, there was the closed quasi 2012 ANCAM meeting. Actually, a year and a half, over a year ago, of 2012 TC4.
Right.
And I'm wondering if you considered the results from that and the discernments of what may have gone into that in terms of preparation and follow-up in terms of informing this account.
Yeah. So I think that was a very successful event. I know Vishnu Reddy pulled a paper together on that. We could repeat that exercise with Apophis, but to me, I would rather really focus on the maximum science extraction we can from this. We don't necessarily have to repeat the exercise, but here's an incoming object. What do we do? To me, this is focusing on what can we learn that benefits science? What can we learn that benefits planetary defense? And I think they're the same questions. But I think from a planetary defense point of view, this is overwhelmingly an overwhelming opportunity to inform planetary defense. Science is excellent as well, but when you start competing science, you have such a broad range of things. So I think of this as more of a planetary defense mission opportunity than a science opportunity, science mission opportunity. I think it can compete, but we've seen what happens when planetary defense aspect missions compete in the science realm. It's just that one little bit that's just like, oh, it's just not quite as much as something else. So I think the planetary defense side of this really is the mindset that's going to carry the day. And we need to support Lindley and Lindley Johnson, the extent that we can support, someone's budget and how he is supported and that budget is supported. This is where I think it can come and can fly. If we're doing a mission, again, I don't want to even prejudge that we have to do a mission. We think about how good can radar do? Can radar do everything we need it to do? Probably not, but let radar make its case, and this will happen to the PDC. What is the extent that all different aspects can do? Could CubeSats do it? Do we have to have a rendezvous mission? I think there's an amazing suite of possibilities here that really need to be carefully thought out, and it has to happen now, because if we ended up with a 2026 launch opportunity, that's pretty fast.
Any other questions online?
All right, thank you.
Hang on a second.
Oh, checking online?
Yeah, we're good.
Good, thank you.
Thank you, Rick.